This is CS1101 Lecture 13.1, and we're going to continue talking about objects. At this point, we're going to begin discussing multiple levels of inheritance. So as a refresher, when we override a method, we are replacing a method, and to do so, we require three things. The overriding method in the subclass must have the same return type, method name, and parameter list as the method to be overridden in the superclass. Overloading is creating multiple methods with the same name. An overloaded method must have the same name as the method it is overloading. However, it must have a different number of parameters, type of parameters, or return type. So either the number of parameters or the type of the parameters or the return type must differ between each of the overloaded versions of this method. So remember the person class that we created previously. It had the instance variable name and then a couple of instance methods and two constructors, right? So an overloaded constructor. One which was the default constructor, and one which accepted a parameter called name, which was of type string. We defined an overridden toString method to replace the default toString method, and we defined an overridden equals method to replace the default equals method, which is given by Java to every object. Then we created a class called student, which was a subclass of the superclass person. So this was a derived class. And we added the instance variable ID. Remember, it's encapsulated, so it's set to private, and we have proper get and also set methods for this ID. Then we have a default constructor, which will call the default constructor for the person class and initialize the student ID to 0. This is an overloaded constructor, so we have a second constructor with parameters name and ID. Name can be passed to the overloaded person constructor, so we can call super and pass as parameter name to call the other constructor in the person class, which will initialize name to the value which is in this parameter, and then set the instance variable ID to the value in the parameter called ID. Then we added these behaviors, get student number and reset, which will change the name and ID. Notice that inside the reset method, we are calling the setName method, which is part of the person class. So this is calling an inherited method. We talked about how often when we are constructing our derived object, we will also need to call the constructor for the inherited class. To do so, we do not use the name of the inherited class. That is only true inside of the class itself. So inside of the class student, we call the constructor student. However, we don't refer to the superclass constructor using the name person. We refer to the superclass constructor using the keyword super. So this is an error. This is correct. This is important because we don't want to duplicate the work, right? We don't want to write redundant code. So the code that is already written into the person constructor, we want to make use of. So to make use of that, we use the super keyword to call the super class's constructor. This is similar to how we can use the this keyword to call the other constructors in this class. So we would be able to call this secondary constructor from the default constructor if we used the this keyword. Remember that? So in the previous lecture, when we were talking about the student class, we never actually overrode or programmed a new toString or equals method for the student class. We only coded it for the person class. We need to do that. Now, the code that is uploaded for lecture 12.3 as an example has the toString method added, but the equals method is left out because the student class equals method works pretty well, and I use that to show that the equals method is inherited from the person class to the student class. So now here, let's look at adding an overriding toString method to the student class as well as an equals method. So what should be printed if a client wants to print a student to a string? Well, probably the student name and the student ID. Remember, the student name is in the base class. That's part of person. However, student ID is in the derived class. What about the student equals method? When are two students equal? So for a simplified example, we can say two students are equal if the IDs match and the names match. Now, like I said, in the example code from lecture 12.3, this is added in, however, this is not. So feel free, as an example, to make sure you're understanding, to extend the code and override the equals method, which is a part of the person class, and add an overriding equals method into the student class. So let's look at how to add the toString method appropriately. So we have public string, so the return type, method name, and parameter list must match the toString method precisely. The toString method, which is defined in person, and the default toString method, right? So this matches, so we are going to correctly override the toString method. And we are returning student : space, and then we're calling get name, and then space get student number. So this will return the name as a string and concatenate it with student, and this will return get student number and concatenate it with space as well as the rest of student and the name. So this works, but it's probably not great for most situations. Can you think of why? In this example, we have a very simple person class and student class, but in reality, there might be a lot of fields in the person class, and it might be cumbersome to write a completely new toString method. So perhaps a better way to override the toString method would be simply to use the super toString method and concatenate onto it any additional information which we need. You see? So rather than completely defining a new string, we are going to get the string, which is returned from the super.toString. So here we're referring to the super class and calling its toString method. So we're going to get this string and then add any information that we want to add to it. So in this way, if this happened to have returned a very large amount of data, we didn't have to write redundant code that printed out the exact same data for the student. So even though we're overriding the toString method in the superclass, we can also make use of the superclass's toString method by calling it and then adding on to it what we want before returning it as the return value from this method. This is the same logic we would use for the .equals method, right? Rather than completely redefining how to compare two students, we can use the super's equals method and then check further pieces as well. So we can use a getName call in student, but if a person had other fields, say social security number, address, etc., that were part of the definition of equals, we'd have a lot of fields as we did with toString, right? So if person were more complicated, and when we checked to see if two people were the same person or if two people were equal, if we checked dozens of things before returning true or false, then duplicating that effort here in the student class when we override the dot equals method would not be a very equitable way of going about writing this code. We wind up rewriting the same code over and over again. So instead of doing that, we are going to use a super call to the person equals method. So inside of our student equals method that's going to override the person equals method, we have to have the same return type, boolean, same name, equals, and the exact same parameter list, which is object with the name other. Then we declare some boolean called result, which we're going to use to store the result of the comparison. And we're going to initialize it to false. So we default to thinking that these two are not the same object. However, if other, which is this general object that is passed in, is an instance of student, and a common mistake that's frustrating is to type in is instance instead of instance of. So keyword here is instance of, not is instance of, and not is instance of. So other instance of student. If this Boolean expression returns true, then other is a student object. If it's a student object, we're going to cast other into a type student and store it in this reference variable called student2. So now we have this object that we want to compare to our student cast into this student2 reference variable. So what we want to do is we want to compare the student ID of our current student. So the implicit parameter is going to be directly accessed so that we're explicitly accessing the implicit parameter and its ID instance variable, and we want to compare it to this other object's ID. And we've cast other into a student variable, so we can say student2.id to access its ID instance variable. So we compare these two. Then we want to further do a logical AND with the result of the person equals method. So what's happening here where we say super.equals and then pass in student2 is using the equals method, which is a part of the superclass person, to compare student2 to the superclass person that is part of this. So if both the ID match and at the person level these match, so person checks to see if the names are equal, then this result will take on the value true, right? Because true and true will equal true. So then we'll return the result of this comparison. Otherwise, it will return the default value, which is false. So in this way, we can use the super keyword to access the equals method, which is a part of this super class, in this case, the person class, and that way we don't have to duplicate the effort which has already been put out. We're not writing redundant code. Now this may seem a little weird right here because we're passing in this student object. Now this might seem weird and confusing because super.equals, inside this method, you probably remember, we check to see if the parameter that is passed is an instance of type person. And you may be thinking, well, this is an instance of type student, so why would that work? That's a very good question. The reason this works is because of inheritance. Student is a derived class from the person class. So any object of type student is also going to be considered an instance of the person class. This is why we are able to call the superclass equals method, pass it a student object, and inside this person.equals method, it will return true when it checks to see if the student is an instance of person. So here's our inheritance hierarchy, right? A student is a person, an undergraduate is a student, a graduate is a student, an employee is a person, a faculty member is an employee, and a staff member is an employee. However, a faculty member is not a student. So this is the inheritance hierarchy. So we would say, if we were implementing an employee class, we would say employee extends person. Person is the superclass, employee is the subclass. Person is the superclass, student is the subclass. We can also refer to person as the base class and student as the derived class. Again, to test this new inheritance setup, we would code a client that would declare the derived object and then verify all methods. So we need to write our test client that is executable, so it has to have a main, and then create the derived object, so a student object, and make sure all of the student object works properly and all of the added and overridden methods work right. And then make sure all of the base class methods work correctly as well. So now that we have coded it, we would need to test it using a client program. It would be really good to download the example files from Brightspace and to play around with it and see if you can write your own equals method that overrides the person equals method. This would be a good way to solidify your understanding of how the super keyword and the instance of keyword function.